Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to Chai with my NLP Heroes, CTDS.show. In this episode, I continue my pursuit of interviewing my heroes from Hugging Face team. I interview the Chief Scientist Officer at Hugging Face, Thomas Wolf. We talk about, as you expect, Thomas's journey into the field. Thomas has worked across many different fields, and we connect the dots of how he followed his passions leading towards finally now NLP and the world of transformers. We talk about his research work and his work at Hugging Face. This interview was recorded a few weeks ago from release, and I'm sure a lot of things would have come out in the meantime, so you can check out the links in the show notes or the Hugging Face GitHub repo for all of the updates or all of the new things that would have come out. In this interview, Thomas shares his overview of the pipelines that he works on at Hugging Face, the research that he contributes to, and the project that he, at the time of recording, was involved in. There are many great advices on how to get started in NLP and in the world of machine learning as well. So without further ado, I'll let you enjoy my conversation with Thomas Wolf. I'm honored to be talking to Thomas Wolf on the podcast, and this is one of the few podcasts where the guest is also having chai. So thank you, Thomas, for joining me on the podcast. Cheers.
Cheers.
So I want to start by talking about your journey. I read that you started by building games. You built a black and white game, I remember back in the day, called Worms. I've actually played it. I really enjoyed it. And you almost recently created a company to build games. Can you share your journey in the world of software engineering?
Yeah, I think I started very young. Well, not so young because the computer was not really existing at the beginning. I'm older than a lot of people in the field, I guess now. But I started with this old Amstrad and kind of black and white computer with the soft floppy disk, the pre one.
Okay.
And I didn't really. I liked more programming games than playing them actually at that time. So
Interesting.
I was doing like a basic the programming language, and then very quickly assembly, because that was kind of the only kind of thing that was really there, and then C and C++, and yeah, mostly just, I guess, your typical nerd childhood, like into program stuff. And then there was the very, very beginning of the internet, but it was really not really there yet. So very slow connection and just a little bit of playing with that. But
Those
yeah.
dial-up connections where you'd hear all that beeping happening as it dials up.
Exactly. Yeah, that was my childhood. The ding, dong, ding, dong, ding, and this. So yeah. No JavaScript or nothing like that. I probably would have had a different childhood, I guess, if I was programming today in today's world.
So, at that time, how did you pick up these languages? Did you find books? Was documentation printed at that time? I'm just curious.
Yeah, that's right. There was no really blog and tutorial on the internet or anything. So I have a few very thick book about C++. And another sick one about BASIC that I read that was really boring to read. So it was mostly experimenting and reading the doc of Visual Studio, and that was the C++. I know I had a Borland C++ in the beginning. But yeah, reading the docs of this stuff and trying to do stuff.
Okay.
But it's a lot easier today, I think, with all the tutorials, and you can just see, and people are explaining that so much better. And I had to find stuff in French, which was not easy as well. It was it was a different time, I think.
Definitely. Fast forwarding to your journey, I read that you worked on some very interesting Tony Stark like projects related to superconducting. What were these about? And do you find any parallels in experimenting in physics versus experimentation in machine learning?
Yeah, probably. Yeah. So most of my so for most of that time and until I think I was well, almost until Hugging Face, just computer science was just a side hobby for me, and I was doing more math and physics, and doing some experiments on low temperature materials and superconducting materials. These are very interesting. They can do a lot of cool stuff. They can, right now we use them to make trains levitate, for instance. They have a strong repulsing forces. And in my PhD thesis, we were trying to use them to detect some X-ray, well, not X-ray, terahertz, like some kind of radiations, and to use that. Now you have that in some airports. You have this very fast scanner that you go in. This is a terahertz scanner, so we will be trying to use them to build something like that. I think it was nice, but experimenting in physics is a lot more difficult than experimenting in machine learning. I think we don't really enjoy as much as we should the easiness of experimenting in machine learning. Physics, you have to buy everything, you have to build the thing, and just building the thing to make it work is already like a huge project. And it can be very expensive also. So often when you want to do an experiment in physics, it's about a few years of just to find the grants, to find like the 500,000 or the $1 million you need to build the thing, and then to build it. And if it's cold temperature, it's usually so in my experiments there were cold temperature plus high magnetic fields, and all this was just full of problems to make it work. So it took like a month to make it work. But in the end, you have like you have nice results. But yeah, that was too long. That was one of the reasons I stopped doing research in physics, like needing 4 to 5 years to make a single experiment, and in the end, sometimes it just doesn't work. You're like, okay, my hypothesis was wrong, so it was just too slow for me. But yeah, there's a lot of experiments. I think there's actually interesting experiments parallel. I mean, with the way we do some kind of NLP right now. In physics, it's a lot about studying one artifact. So you have, for instance, these specific materials that you try to understand, or these specific particles that you try to track and to understand. And right now, we do a little bit with our models. I think that I find this funny. We try to study birds, like birdology. We try to understand how our models actually work and why do they work. And it's kind of the same thing. You have this artifact and you try to understand, okay, but what's happening in this? And can we use this for something? Can we improve it also for something? But yeah, there's this thing. I found this interesting. But yeah, there's one big difference. I think that's something I try to push here in ML also is reproducibility. It's very hard to do reproducible experiments in physics because the thing changed, the weather changed. Today it's raining, and actually your cold temperature setup doesn't like the rain as much as you wish, and so it doesn't work. And in ML, we can have almost perfectly reproducible experiments. I think we don't use that as much as we could. Actually, we should be able to really share something that is fully reproducible, because that's really how science works, and that's how we should do.
Yeah,
I think that's what we should do more in the field. But yeah, there's some parallel. And also the late night working on experiment that doesn't work. This is definitely something that's everywhere in science. And you're like,
in machine learning, it's definitely much easier. You can just shift enter, start an experiment. If you're training a GPT-3, you might end up spending similar amounts, but otherwise it's mostly cheaper. So I want to highlight an aspect of your journey, and this is my perspective. Please feel free to correct me if I'm wrong. I observed that it's always been a pursuit of passion for you. You worked across different fields. You even turned down a PhD acceptance at MIT. Can you highlight that? How do you how have you been pursuing your passion? And many people are even scared to take the jump in machine learning because it's slightly new or slightly outside of their interest.
Oh yeah, I think it's It's kind of hard to describe because in the end it's a lot of random choice. Maybe I was also, a lot of people know what they want to do when they're like 20. They're like, okay, this is what I want to do. I didn't really know what I wanted to do. I was like, okay, there's a lot of things I would like to do. So I did some physics, and I was like, oh, this is really too slow. And then I had a friend. It's also a lot of people, you know. I had a friend who was doing law, and he was like, oh, you can do patent law. And I was like, okay, why not? Then I studied law, and I was like, oh, this is actually super interesting. I think it's all about the stories of people, things happening. There's a lot of logic as well. In law, I was surprised. It's because there is this thing and this thing, then together you have to actually do this judgment and this decision on something. So that was also very interesting. But then it had the other problem than physics. I think it was going too fast. You had a lot of small projects, but you were not really building one big thing. And I was missing this thing. And yeah, and then it's a bit random. I actually came to ML because I was supposed to come to the US, and all my law degree were just worth nothing because
Interesting.
law is different in different countries, right? And so I look at the law school. They were super expensive. I had to study it for 4 years in something that cost like $100,000 per year. And I was like, okay, I'm not sure I'm ready to do that. And at that time, I was writing some patents for a company doing deep learning. That was the beginning of the revival. It was 2013, a bit after 2014, 15.
The AlexNet era.
Yeah. And so it was mostly computer vision. And when I was writing their patent, I was like, oh, actually, this is all physics equation. People call them like optimization, machine learning, but this is all free energy minimization, all the thing I kind of knew from my physics background. So I started to actually look into what was really machine learning. And then at that time, Julien was founding Hugging Face, and we were friends from the university. We actually had a music band together. Julien was playing the bass guitar, and so
what were you playing?
and I was playing the keyboards.
Okay.
I still play a little bit. And so he was like, we will be incorporated in the US. So if you want to come work in the US, that will be easy for you. Why don't you come do some science at Hugging Face? Like, okay, let's try and let's see how it goes. And what was supposed to be kind of temporary became actually a big journey and a big venture. So, yeah, this is a bit random, right? You say. So I think, yeah, but I think it's nice to change. But that's my personal view. After a few years, often I need to kind of change and do something else because times fly by too fast, right?
It's inspiring to me because I'm the idiot who drinks chai and asks stupid questions to many smart people almost as a full
No,
time
you're
side
not.
hobby. So I'm not as afraid to just try this for a while. I think it's interesting if you're driven by passion. You get a lot more out of your work.
You also change a lot, right? When you started to do fast AI and now all this can go very fast actually when you do. You're
You don't
surprised.
realize how fast it goes, I think.
And then you remember, you're like, wow, 3 years ago I was doing that. That was totally different than what I do now. So.
Absolutely. So I've already interviewed Julian for the audience. You can check out his interview for the complete story of how Hugging Face started. But I want to talk about another aspect. You're a fan of what you call offline learning, which is not first resorting to online resources and learning with small groups. What are your favorite resources of getting started in NLP or machine learning?
Yeah, so I think everybody has a different way to learn. That's right. So maybe that's how I grew up, but I don't really. When I read blogs, I forget them too quickly. So I usually like to buy books. So I bought a few very big books and I just read them from cover to cover. Usually, I like doing that. I think it's nice because there is still something when you think everything is in blogs. It's not really true. There's a lot of like knowledge that is maybe just too general or just too specific maybe, and which you won't find in blog, and you have to read actually a good book. So there is always stuff in a nice book in the field that you will never find in blog. So yeah, I think sometimes people are just too superficial when you just read blogs. You only read things about the latest trends, and if you want to read back about what is the A-star algorithm in AI, what is this whole thing, like what are actually Bayesian networks, if you want to understand this, you have to read the book, I think. And it's important to kind of know this thing as well if you want to do research, because then you won't be reinventing the wheels. We're always like, oh, this is a good idea, and then when you look, you're like, but actually people thought about that 20 years ago and they tried it and they did already a lot of stuff, so I should just start from where they ended up if I want to continue in this field instead of redoing what they're doing. So yeah, there is this thing about knowing what was happening before. But yeah, then there is a lot of things. I think what was really good also for me was the course like Coursera, and I took only one class, I think, on Coursera, the Bayesian network class by Daphne Koller.
Okay.
But there is also IDX. I took a probability class there. That was really nice. And I think this is really great because you have like a real cursus that's done by somebody who is good in the field, and you have exercise, so you're kind of forced to move forward and just rely on what you've been reading fast. And doing small groups is good. Yeah, that's how we started with Julien. We did a small study group to follow Stanford NLP class.
The 224 standard,
yeah.
one of the most famous courses.
This is a really nice one. It's fully accessible online, so you just but there is no curses, so you have to force yourself to follow there is no reminder, oh, you didn't do your exercise today. So it's good to do it with other people, so you have some kind of a way to move forward and to try to keep a schedule and to try to force yourself to do it every day. But yeah, in general, I think like a lot of people say that, but the way to do that is just to kind of force you in the beginning to work on that every day. And then after some time, you start to, it's like a language, you start to know it better, and then it feels good. And then you're actually happy to come back every day to do your study. And so following a class is nice, or reading a big book. So every night you can read like a such page or something like that. And you feel like you move forward. There is stuff you won't follow because there is just too many knowledge, but it's okay. It's okay to forget some stuff. But at least you will know, you'll be like, oh yeah, I heard about that, and I can find it back in my book, or I can find it back in my online class. I know it was in this video, so that's already very good. And on the favorite resource, so I have a list on my website. That's probably the best thing. In NLP specifically, there is two nice, I think, books. Well, three nice books. So it depends what you do, what you like. The first one I like was the one from Kyung-Gung Cho at NYU. And then a bit later, Yoav Goldberg did a nice book as well. And then more recently, oops, what was his name? I forgot now. Jacob Eisenberg. I think I missed you can read on my website.
I'll have it linked. I think you have a TXT embed in your blog. I'll have it linked in the show notes.
Yeah, I think one thing about NLP, one specific thing that you would like, it would be nice if you know a little bit about linguistics. That's something that's missing often about when you just read ML classes, like when you just follow the Andrew Yang and these pure ML classes, you will miss a lot of things about what is linguistics, what are the words, what are adverbs, and this is actually important. So yeah, it's good if you read something specific about NLP as well.
Okay. What was your takeaway from following these resources? What did you find helpful to learn faster? Because you already had the rich mindset of having worked in physics. You were sort of new to machine learning. What tricks or what approaches did you find useful to be more efficient in approaching these materials?
That's I don't know how much it can be shared with other people, because a lot of people just do their thing. I mean, learn differently.
Yeah.
Yeah, I think for me, I think just reading a lot and allocating some time every day to read something. I think it's important, like everything, probably the more important is to try to allocate your time to things that are important. So time is the only important resource in your life. That's the only thing you really cannot buy, you cannot get anymore. So when you spend some time on learning something, you should try to be sure you're learning from good quality things. So it's not really worth it reading 10 times the same blog post about TensorFlow or something like that, for instance. But if you read like from a good quality, or if you follow a good quality class or something that people say it's good, then you're using your time wisely. And if you spend a little bit of time every day on this, then that's good. And then I think something important is just to keep reading and also having different perspectives. So when I told you there is like 3 NLP books, it's actually kind of interesting to read them all because they're all quite high quality, and they all kind of talk about the same thing from different, angles, different
Perspectives.
view. So then you're like, oh, okay, this is actually this I did not understand in this class, but now I see it from somebody else, and I'm like, okay, now this makes sense. So yeah, this, and then at some point you start feeling good in a field when you know what you don't want to read. So there is a lot of paper in archive I just will never read, and when I see the abstract, I'm like, no, that doesn't interest me. And that's when you feel like you kind of know the field enough to know what is interesting for you, what is important for you. But in the beginning, it's always the same. You read all the paper in archive, and you're like, oh, they all look interesting. I want to read them all, and that's normal. But just be aware that it means that you're not really familiar enough with the field yet, and that you still need to learn more. So right now I read a lot less paper, I think, than I used to read in the beginning, because I kind of tell very quickly the paper that interests me from the paper that don't interest me.
Okay.
Yeah.
How did you approach implementing the knowledge? Because a few of the books you mentioned are more theoretical. Papers are definitely much more theoretical. What steps did you take to understand how can you best implement these stuff, these algorithms?
You mean in code?
Yes.
Usually in code, I kind of start from code from other people. So when we talk very specifically about transformers, the idea is usually, because also when you read a paper, there's a lot of details, well, that's something people learn at FastData, I think also. There's a lot of details that are not mentioned and that are actually super important. So if you just read the paper, there is the story that the researcher wants to tell you. And then if you look at the code, there is the real story of what happened. And this is sometimes it's very different, right? And so when we implement the code in Hugging Face, usually we wait for the authors to open source their code first, because we know there will be a lot of small things that are actually very important to get the result, and they will only be in the code. Can be because most of the time it's because there's not enough space in the paper. Sometimes it's because actually the sad story of research is that some details are actually more important than the main idea they would like to sell you. And so we know that. So yeah, you need this. So when you want to start coding, there is no, you have to code, and you have to. But for this, I think Fast.ai is probably the best way to start, right? With all this very practical implementation detail that are actually super important. You need something definitely in addition to books, and this you need to practice and to read the code of people. Yeah, but that's one of the reasons we wait. Sometimes people are like, "Oh, this model is published. Can't you implement it?" I'm like, "No, we will wait a little bit. Let's see."
I think, like you mentioned with papers, even with code, you start to see these similar snippets over time. So then you sort of mentally build a model of, hey, okay, here's what's going on. And initially, there's a learning curve there as well. Even for people who have the theoretical knowledge, if you just start downloading the implementations and just running them, there is a learning curve to understanding that as well, I think.
Yeah. Yeah, that's right. That's something we try to. I mean, in Hugging Face, it's sometimes very easy to run the models. So I think people don't really go read the papers. And we would like to push them to read the papers more. So in the beginning, the idea was that we were on purpose assuming that you had read the paper. So for instance, BERT, well, now BERT is kind of in the common knowledge, I guess.
But it's too old now.
Yeah, but it's old. But in the beginning, there were like these token type IDs, for instance, that people didn't really know about. But that was explained very clearly in the paper. So every time people were asking, we were like, just you should read the paper. That's important because just using the code, you're missing also a lot of things. These are the two things go together. That's right. Yeah. And now we would like to, that's the current thing we are also trying to push, is to connect this more also to the data set that was used for training. Because there is the modeling approach, there is the model of BERT, there is how it is trained, how it's explained in the paper. But we see more and more that actually what was the exact data set that was used to train it is maybe as or maybe even more important than actually the architecture. I mean, the architecture of GPT-2 is very simple. GPT-3, there is a little bit of sparsity, but they're all very, very simple. And most of the magic happened because the data set is very big and is carefully curated and is nicely made. So we would like to connect also this thing more.
Okay. For people, Thomas just mentioned the FastA course. I would like to mention the FastA NLP course where they teach the basics of all of these. Apart from that, I would mention one blog post that Thomas himself writes on Medium. So check out all of his blog posts. You'll get a lot of knowledge from there. If you are not sure if you should read any blog posts. So I want to now talk about what does a day in your life at Hugging Face look like? You're the chief scientist officer. What does a day in non-pandemic version of the world look like in your life?
I think it changed a lot recently, I would say. So a day of my life now is a bit different than it used to be at the beginning of the year. Mostly because we've grown a little bit. So Hugging Face was always a very small company, I think, in terms of, well, we didn't want to grow like some startup do, I would say, maybe.
Mm-hmm.
So for a long time, we were less than 10 people. And now we grow a little bit this year. Now we are 20. But it's still like a very small team and everybody is very independent. So
I
the
think
nice
still
thing...
hiring, right? For anyone in the audience who'd like to apply.
Yeah, we are. We don't really need more people. It's mostly that when some people that are very good apply, we kind of let them go. It works like this. So we're not actively. We need a little bit of people more on web design. We would like to improve the website, for instance. So this we actually need people. We are really looking. But for ML and research, it's mostly just based on some really good people that want to come, and we're like, okay, you can come, but we don't have some specific project that we need people to work on. I would say. So yeah, feel free to apply. But if you apply, just tell us what is really cool about you and what you want to do. We expect everybody to be autonomous. Pretty much everybody at the company has his own project that he has selected himself, and most of the people actually came with their own project. So when you want to come, we're like, okay, what do you want to work on? Because we don't have any specific project for you. You come with your own project and you'll be the master and the lead on this project. So it's very autonomous, and basically a lot of people are very senior, I think.
Okay, I'll have the jobs profile in the show notes for anyone from the audience who'd like to apply.
Yeah. So for instance, if you want to come, Sanyam, probably we would say, okay, do you want to like continue doing your Chai time and do your community? And this is really cool. So yeah, this is the kind of thing this is the way we hire. So the nice thing about that is that I don't really do a lot of management, so I can still code a lot, which is really cool. And this, I'm not looking forward to the day where I won't have any time to code anymore. So, so a good day is when I can code. A bad day is when I have to do administration stuff. So today is, this morning was administration, but now this is nice because we chat a little bit. Yeah, so we do a lot of coding. Now I code a little less also because some of the people in the team are really better than me. So it's actually better if they code what I would code. So this is a bit frustrating, but like my two current main projects, definitely the 4 people working on this are all just better than me. So I just try to follow what they do and say, oh, yeah, this looks really great. That is better than what I would have done myself. But yeah, so I started, Transformer was starting to be a little bit big also. So I started this dataset project about sharing dataset, which is also now growing a little bit big. So maybe I need to start a new small thing that I can control and manage myself. We'll see. If you have ideas about a new project that I'm missing.
Okay. So typically, what all projects are you working on? I know you're also involved in research. We'll just get to that, but usually, is it again independent, varies a lot from day to day, or do you have a structure about the projects that you work on?
Yeah, it depends. So there is a mix of, I think, long-term direction we want to push. So I think the main idea is that we want to build stuff that kind of are beneficial for the whole community. So there is this long-term ideas about good thing we would like to promote. So at some point it was, for instance, sparsity and efficiency. So you would like to push this thing because I think it's important that people can leverage this. Reproducibility, there's this long-term direction that we want to push. And then there is all the things that are happening, and sometimes you're like, oh, actually, we need to do this because it's the right timing to do this. So there is a mix of long-term goal and then short-term kind of opportunity. We're like, oh, okay, this is really cool. Let's do this to also keep the fun. It's kind of fun to be like, okay, let's do this in a few days, and then the people will play with this model, and it will be very nice.
I just turned around because I had the website open and I just wanted to read out the goal, which is on a mission to solve NLP one commit at a time. So I think the mission has been the same since the beginning.
Yeah, it's always about, it was always a community kind of project, democratization and kind of being very connected to the community in the field. Now the way we do that has kind of changed. Now we saw that building tools is actually a very good way to empower the community. So that's what we do the most right now. And at some point it was maybe more teaching. I think we should be teaching a little bit more as well. We don't really have enough time, but
we really hope so.
Yeah, I wish I could do more. Like we started, for instance, this YouTube channel, and I only had time to do one video. And I have another one in preparation, but it's been in preparation for like 3 months now, just because open source tools are like, yeah, I don't know, they look more important right now. But yeah,
okay.
Time is limited. We have to allocate the same day.
So how do you manage your time across different projects? One thing I've learned after joining a job is that there are many projects that are happening and you need to manage your time. How do you do that?
Yeah, that's right. Yeah, there's always too many projects, right? So yeah, it depends on the people. Personally, I'm very bad at multitasking, I think. So I usually need to have just one project at one moment, and just finish it, or finish like a version I'm okay with and then switch to another one. But some people likes to have like 2 or 3 projects at the same time. They feel better when they can. So it depends on how you feel. But me personally, I usually try to have just one project, and then I finish it, and then I switch to another one, and I choose it based on the most like important right now, and also the one I want to work on the most. But yeah, also when you start to have a team, like a lot of people do the nice thing, and you can end up doing the thing that just nobody wants to do. So you do the documentation because nobody wants to write documentation, have the testing because nobody wants to do testing. So. But I mean, this is part of the thing. I also want people in our team to have fun and work on interesting things. So like right now I work on the tokenizer in Transformer because they need a refactoring, and just nobody really wants to do that. People want to do models, they are fun to do, but tokenizer, nobody wants to touch these things. So, well, we now have a few people like Nicola, Anthony, they share my interest for tokenizer, which is nice, but this is a rare skill. People like models, but they don't really like what's around the models. This is just... yeah,
like you mentioned, it's from what I can understand, there's autonomy and responsibility. So it's up to different people. Like for example, you took responsibility of refactoring tokenizers.
Yeah, this is really how we work.
Okay.
Sometimes people also feel that there is also a bit less mentoring that there could be in other company. Like I guess if you go to Facebook or Google, you have mentor that you can have regular feedback, and here it's more like, now you're in the team, do your stuff, and everybody just tell us, and we tell you that it's nice, and we give you feedback, but you're like autonomous.
I get to work at a startup H2O.ai, and I really enjoy this approach because we also have a similar approach where we have a culture called makers gonna make, and there's complete autonomy. You need to tell other people what ideas you're working on, and then they'll guide you to some extent.
Yeah.
So coming to research, you're also involved with the research community. At the time of recording, I think you were involved in the SUST AI conference, and you have contributed to other conferences as well. Why are these important to you?
Yeah, it's the core of what we do, is like trying to do this. That's behind, like the way we do NLP is to try to make this new breakthrough easy to share. And first was among researchers, so just researcher could reuse also themselves these new models as baseline very easily, and they could modify them to experiment with them. But in the end, we also, like everybody in the field, we're kind of passionate about these NLP models and how they work and what they can do. And so we also have this research team, and these great research people in the company trying to make these models better and trying to see what are the limitations, where we can improve them. And this is something I'm very interested in, and I've always. So right now I do a lot of open source, like since last April, I think I have a long run, but then I really wish I could spend more time on science as well, because there is some super interesting things. So I'm mostly, indeed, I'm organizing this workshop. I'm co-organizing this workshop called Sustain NLP. It's mostly for NLP right now. It's a workshop at NLP, where we try to promote like more efficient approach. So we got a lot of papers. I think that was nice. So now they are under review.
Mm-hmm.
I don't have enough time to really help the team, but it's really big. There is a big organizing community. It was started by Nafis, and there is a lot of people in the committee. Actually, it's really a big group effort. And we also did a competition, but it didn't really work out, the competition. I think mostly because it was during the COVID, and the worst part of the COVID, where everybody was just overwhelmed by too many things.
Yeah.
So we probably try to do it again next year.
Last year, for the audience, I'd like to mention you had taken part. I forget the name of the competition, sorry, but you had absolutely smashed the leaderboard. I think it was for dialogue-related bots.
Oh yeah, that was we did a Convey competition.
Yes.
That was in Europe. Now it's 2 years ago. Yeah, that was kind of nice. It was the first time people kind of used the transfer learning model for doing generation in dialogue, at least. So it was GPT, the first big transformers. And it worked really well on the automatic metrics. We really smashed the thing. Well, right now everybody's like, of course you start with a pre-trained model, but at that time, just nobody was doing that. That was just the very beginning. There was the first paper by Alec Radford, and before Bert. So yeah, that was a nice thing. So also this year there was nice competition. We thought about participating, but yeah, a bit the same. It was at the bad time of COVID, and then we had just 3 projects at the same time, so we didn't do it. But yeah, definitely research is something that's alive at Hugging Face, so that I personally wish I could spend more time on. Probably follow what I do next at the end of the year, when all the open source thing are kind of finished, and we can let the people play with them, and go back to science for some time.
Just trying to understand your approach to research. Earlier, I know you've contributed to the few research projects as well. What does a research pipeline for you look like? How do you approach research projects?
Yeah, I think research is tough. That's also why I do open source sometimes. Like, it's kind of easier to do a nice open source project than a nice research project. I think the main problem with research projects is that often your ideas just don't work. So you need to do a lot of different. You need to try a lot of stuff to get to the one that works. So yeah, that's what I see. The nice research projects, for instance, like the recent paper of Victor. I think Victor is really good as a researcher. Is trying to investigate something, like just trying to understand what's happening, and then in the meantime, often you start to have ideas about how you can improve this thing. But basically, if you want to be a good researcher, I think you should be always experimenting. Like, you should have always a few experiments running, that you're trying ideas or analysis. It's all about, well, there is a lot about just how many different directions you explore, and being fine with just things not working, like being fine with 90% of your experiments just failing, and just because maybe the hypothesis is not right. And sometimes it's frustrating because the hypothesis makes a lot of sense for us humans. We're like, this is how it should be, but the models, they don't really work like humans. So yeah.
You also need a lot of RGB in your PC, otherwise your model stays slower. We've been debating this on Twitter for a long time.
Yeah. Definitely.
Um, so Hugging Hugging Face lies at an interesting intersection of research and practice. You've also made a video and written a paper on this. What are your favorite trends from NLP in academia and industry in recent years?
Yeah, there's a lot of things happening right now. I think it's very interesting. So personally, right now, what we are working on, and as I speak, like I should be working on that right now, but is open sourcing some models where a part of the model is a knowledge base. This is one. Well, there's a lot of things, but this is one thing I'm working like this week, for instance. We work on that with Facebook team. They have been probably the one that have played the most with this. There is another Google team, but yeah, there's a trend of recent model. They are called Realm, RAG, DPR, Orca. These are the models where the models actually query a database. It builds itself actually, but this is kind of the training set encoded in the models, and it uses this database to answer. And this is kind of nice because there's a lot of things in life where actually you have a single example that something happened to you, and it's very important. It's enough to change the way you act, for instance. And this is very hard to get for the models because our models, they are trained in this statistical approach, and they did a lot of examples to understand that this is actually important. So this way of querying some specific example that happened in the dataset and using that to augment the performance of the model during inference is, I think, very powerful. And another related thing is that you can have this database evolve. So for instance, right now, the president of the United States is Donald Trump, but sometime in the future it might change. And you can just evolve this database so this model can learn continuously. And this is very nice because when you think like GPT-3 was very costly to train, but it will always have the same training dataset, right? So in 3 years, this dataset will be kind of outdated. Already now, GPT-3 doesn't know anything about COVID, which is a bit sad because it's a big part of our current life. So continual learning is something we want to have definitely in the future. And so these are some of the topics we like. These models, they can be also make smaller, so they are more efficient. Yeah, this is one of the research projects I work a lot right now. And then evaluation and metrics, and also metrics for generation, which is kind of a tricky field, is something that I like a lot. Well, I like a lot. I think it's very important to the future.
Okay. I think it might be out by the time this interview goes out, so be sure to check out Hugging Face's GitHub. One thing that has come out recently is you've just announced the API pricing. Can you highlight what will that allow practitioners to do? And I think Hugging Face's goal is to create conversational AI and also advanced research. Does this tie well into that as well?
Yeah, that's a good question. So Hugging Face has evolved a lot now. So conversational AI was very important for us at the beginning. Right now, I think we understood that this is just a small part of what we can do. It's actually more interesting to work a bit higher on these models that can be used for many tasks. Yeah, right now we're really more in this higher level of helping share these models that are, can be used for text classification, token classification, conversational AI, summarization. There is so many common points now in the model powering this different application that it makes more sense to work a bit higher in the hierarchy. Regarding the API, the idea is that we have this super strong DNA of sharing, open science, open research, open sharing. That is just the way the company was built, basically. And we want to find a way to monetize that makes sense with this. So there are a lot of good examples. I think there is like GitHub, there is also like MongoDB, there's this open core company. There's a lot of companies who manage to have this mix of very open source thing with a business model. So one of the idea of the API is that when something is actually more interesting for companies than for researcher, then maybe they can just pay for it because they have like also some money for it. So one interest for us is, for instance, to give like a faster and just I would say industry level access to this model. Like if you want to use them with something that has actually a high bandwidth, where you have a lot of queries, we can just reuse this API that we've opened this API at the beginning for people to inspect the model very easily. So you have your model, when you upload it, it's actually live on the internet and people can play with it, can see also what are the limits and how it can be used. And we're like, why not also making just a super powered version of this API that you could plug in a product. So that's something that makes sense. And it managed to, I think, make something that's interesting for company who just like one good example, for instance, are the translation models that we have. We have about 1,000 of them, so that's really a lot. And they are made by a really nice team at Helsinki NLP, York Tidemind. This is really a nice team. They have made an amazing corpus for training them that is powering actually a lot of application like Reverso. I don't know if you know this, but yeah. And these models, they're actually just better than Google Translate, for instance, because they are trained for, Google Translate is this big machinery that is trained for a lot of different languages and trained at scale. So it's actually not the best translator you can find. And these models are better for many languages. So we were like, yeah, why not giving access to this model very easily if you want to power like a translation service or something like that. So yeah, that's the idea. We're still kind of experimenting. I think this is the first step. And there's a lot of other things we could give access to that are just actually additional things on top of all the open source product that we provide.
But Hugging Face won't turn evil. It will continue contributing to open source and research. And from what I understand, people in the industry could just use the API to implement these models or bring these things into their ideas, their products.
Yeah, the idea is basically this. So probably in the future, we'll try to also make a lot of things that are, I mean, you can do everything with a library, but sometimes you need to know a lot about PyTorch, about TensorFlow, about deep learning. And one idea is also we should make it very easily for, like, I don't know, data scientists. They don't want to, or they know a little bit about deep learning, but they don't really want to spend like 2 months really understanding deep learning just to see if BERT will work on their product. So we'll probably also do something for these people, just keeping this very open core for researchers and people who are like kind of very familiar with NLP and deep learning, and making also more like easy access product for people who are less interested in that, but more just want to try it on their business use case or more to try it on their data and things like that. It's basically reaching a new community for us. A community of people who are maybe less aware of the mystery of birds and the inner working, and they don't really want to, well, they don't have time to really dive into that, but they would like to use them. But yeah, we'll keep this open source and open research. This is just the way we do things. And yeah, I think this is also why we have fun working in a company. So
That's really the next step of democratizing, like you said, NLP, which is to put these things in the hand of people who don't really understand it and haven't gone through the training.
yeah.
So the next question is by John Matthew, who's from H2.ai. Will you be adding explainability techniques with transformers? He's referring to Export, a visual investigation tool that I think was added recently a few months ago.
Yeah, this is really very important, and this is a very good question. And if Jean want to help, you're very welcome. I think this is super important, and I wish, well, it's not that I wish, we are working on adding more stuff. Actually, one of the reasons also we are developing this new library about the data set is that a lot of these explainable techniques, they kind of involve the data set that was used to train the model. You will retrieve, for instance, similar example in a training data set to try to explain why the model predicted this. You can say, oh yeah, this was the model predicted that this girl was a nurse, because if you look at the closest example in the data set, it's always about nurse, for instance, or something like that. So our idea is that if we have a nice tool and a very fast tool to explore the data set, we can also add more explainability. But yeah, we really want to do that. And the main reason all these models are like open on the internet and easy accessible is actually for people to understand them better. So right now it's just the beginning. We would like to make them even more open. We like to break the black box of deep learning and make it very, very open. It's a natural extension, I think, about our idea of sharing this very easily, sharing the model, sharing the code. The next step is actually making it easy to see inside what you've shared, what is inside, and to understand what is inside. And there's a lot about education also, right, at the same time, because if you can see what's happening inside of BERT, you can understand what's happening in the model, you understand the model, and it's a way to educate yourself about how BERT works, just because you can access what's happening inside. But yeah, that's big direction for us.
Definitely exciting times up ahead. So this is one of the repeat questions. I usually try to get different perspectives on it. What best advice do you have for someone who's just starting out their journey in the world of machine learning or NLP, for example?
Yeah, that's very difficult because everybody has a different way to do that, right? I think maybe a good advice is to try to start building something. You should start building a library or start, I mean, also a lot of people now who have joined Hugging Face, they joined because they contributed on the repository, something very like strong contribution. We were like, wow, this is really cool. Do you want to come and do the same stuff, but inside Hugging Face? So, and it's the same for a lot of big repository. I know like PyTorch, there are a lot of people in the team that were just contributor at the beginning. So doing this is a good way to bootstrap yourself. I think just coding, but you have to do a good contribution. But I mean, that's the idea. Or if you don't really want to do that, starting like a repository yourself on something that is interesting and that catch the attention of the community.
I know, for example, in FastAI community, many people have used integrated Hugging Face into FastAI ecosystem. I think one project is called Fast Hugs, if I remember correctly. So many people are also
Yeah, I
doing
think.
such projects.
Yeah, this is nice also. Yeah, definitely. It's by Richard Wang, I think. Yeah, probably. Yeah, I think I added him. He's on a. So a lot of people are now. Usually, when we see nice project, we add people on our Slack when they're like really close to what we do, so we can keep them aware of where we're going. So I think Richard is one of the people we added recently. So we can keep him aware. We say, okay, next step will be changing the name of the library. So you should prepare yourself. You should prepare your repository.
Interesting. So I've started sort of a funny special rapid fire round. If it's okay with you, I'd also like to give it a try with you.
Yeah, sure.
What's your favorite game of all time?
Of all time. So usually I build games. I don't play a lot, but I think and right now I have kids, so I mostly play with kids game. So Fortnite right now I would say. But in the old time there was Civilization. I think the empire like building stuff. That was really cool.
You don't play the sandbox game that you actually created. You don't
Oh
play that
yeah,
much.
I thought video game. Yeah, real life game definitely. So there is this sandbox. Yeah, build with my kids. Um, yeah, no, that's yeah, that's yeah. I like build stuff like this, all this maker like Steam education stuff. Like when you build games, electronic games with your kids, we have a lot of this. This is kind of fun to do.
Okay. Favorite NLP model? You could name any.
Favorite NLP model. Let me try to mention one which is not too famous. I think I kind of like GPT-1. That was mostly because it was trained on books, and there was a lot of romance and love books. And actually, when you talk with GPT-1, it's kind of cheesy. I found this very cute. It likes to talk about relationship and romance and things like that. So I think this is a cute model. We've lost that in GPT-2, which is more like Reddit trained. So there's definitely a lot less romantic stuff. But GPT-1 has a nice taste of, it's like old music, now these old models, you're like, oh yeah, I like this model from the 90s.
Interesting.
Yeah.
Favorite, I was going to ask favorite transformer model. You've already named one. Favorite NLP model that's not a transformer model. Architecture, algorithm, anything.
One that was not in Transformer. There is one I wanted to add in Transformer, which was, but it's kind of old now. It's Deepmoji. That was a model by Bjark Felbo. He did that at the MIT in 2016. And that was, I think, the first transfer learning that really worked. It was trained on 40 billion tweets, something like that. And it was trying to predict the emoji that somebody would add to its tweet. So they removed the emoji, and so this model can predict emojis, 64 emojis, and it's actually very good at sentimental detection. So we don't have that in the library because it's an LSTM, but we could definitely add it, just also because it's a bit old. But yeah, last winter I almost added this one, the Deepmoji one.
Maybe someone from the audience could contribute it and end up working at Hugging Face. Who knows?
Yeah, we already have a PyTorch version at Hugging Face called Torchmoji, but that was done for PyTorch 0.2. So you would have to upgrade a few operations if you want to use it. It's a nice one. I think it's still pretty good in terms of performance.
Okay. Favorite computer vision model or algorithm?
Ooh, I'm really bad at computer vision. It's definitely not my field. I read the YOLO paper like everybody. I like them also because they are funnily written. And right now, recently, I asked for a list of nice CV paper, but I haven't had time to go into them. But there seems to be a really nice thing, right, in self-supervision and all this kind of thing. Like, yeah, but maybe we can talk about that in a few months when I've updated my knowledge of the most recent CV algorithm.
Yeah, semi-supervised learning is definitely one of the trends of 2020.
Yeah, what's his name? Simclear? Yeah.
Simclear?
Simclear? Yeah, that's this one. Yeah, this looks really cool.
What's your second favorite emoji? I know the first one might be hugging face emoji.
The second one, it's probably just laughing. I like to. You never know how to write something about something that you find funny. You write haha, but it doesn't sound good. So just the emoji of laughing is probably my second one. Yeah.
Fair enough. I left this as a final question. Victor gave a very diplomatic answer. I'll try to get one out of you. PyTorch or TensorFlow?
Yeah, that's tough one, right? I'm kind of the one who added TensorFlow in the library, so I think it's very nice. I think
so TensorFlow?
Yeah, TensorFlow is good. Yeah, I think TensorFlow 2 is nice, and you can do a lot of things. But then, yeah, there is this difference. When you go deep in TensorFlow, you can feel that it has been written by 500 different people. And so on PyTorch, you can feel that it was written by just 2 or 3 people and with this very strong, opinionated decision. And so it makes it a lot easier, I think, to dive into PyTorch and to TensorFlow. Yeah, they're too different to say one is better than the other.
Looks like my pursuit to find one single framework from the Hugging Face team will continue.
So right now we're adding Flax and Jax in Transformers. So we added Flax, but Flax is now being renamed. Actually rebootstrapped as a Linten, and this looks really cool as well. I think Jax, this is kind of cool.
I sort of look up to Hugging Face as the Apple of NLP. So I think it really speaks to that you're always at the cutting edge while bringing innovation and also making everything faster and more efficient.
But yeah, we are very expensive as well. That's what you mean.
Not that part, maybe.
Yeah. No, that's true. And we have a fast release schedule where you have to update always all your things too quickly. So there is a lot of common points, I think. Yeah.
Okay. Thomas, before we end the call, what would be the best platforms for the people to connect with you?
Yeah, I'm pretty open. So I think LinkedIn is kind of noisy. So if you send me a message on LinkedIn, I just have too many messages. But yeah, email or Twitter. Yeah. One thing is that I never really do a short calls or something like that. So it's better if you send me an email and where you explain your stuff. I just
Okay.
yeah.
You can find Thomas. I have your Twitter profile open at Thom__Wolf, and if you maybe connect with him on LinkedIn, send him a T emoji. Maybe he'll accept your request once.
And also we have a forum right now, which is very nice. It's at discuss.geekface.co. And if you have like question, it's usually better to ask there, because I do have a lot of people asking me a question and I don't really have the time to answer to everybody. I mean, question about your training, your model, it's usually better if you post on forum and a lot of people answer. And if it's actually relevant to what I am currently working on, I will be pinged by the team and give you an answer. But yeah, this is I think we're really happy about the forum. There is a nice activity and there is very good people giving answer there. Yeah.
I'll have all of these resources in the show notes. So please scroll down and click on the links that you're interested in. Thomas, thank you so much for your time and for all of your contributions to the community.
Well, thanks a lot. It's very nice. It's really a nice podcast. So yeah, keep doing that.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.